Hi guys, and welcome to another video. Today we're going to be looking at the fundamental counting principle, and we're going to be looking at a question on seating from the February-March 2014 examination paper. Now, in this question it reads as follows. 8 learners are seated on 8 chairs in the front of an assembly. So therefore, the number of items that we have to arrange is 8. The number of places that we have to arrange them in are equals to also 8. In how many different ways can these 8 learners be seated? Now, to answer this particular question, we have 8 items that can be arranged, and we have 8 places to arrange them in. Therefore, n factorial all over n minus r factorial is a formula that we use. But because the number of items that we have to arrange and the number of places that we have to arrange them in is the same, our denominator will be 1, because we'll have 0 factorial. And remember, 0 factorial is equal to 1. Therefore, we will just have the number of items that we have to arrange, which is the 8 learners, which is 8 factorial. And 8 factorial, and 8 factorial is equal to 40,320. Alternatively, could answer the question as follows. Draw our 8 places and write down our number of items that we have to arrange, decreasing by 1 each time in the number of places. 8 learners. In the first position, we have 8 learners to choose from. Second position, we would have 7 learners to choose from. In the third, we'll have 6 learners to choose from, and so on, until we reach the end. And if we multiply all of these numbers together, we will get 40,320. And there you go, 40,320. So let's answer 4.2. In how many different ways can the 8 learners be seated if 3 of the learners must sit together? Now, this is the purpose of today's video, to show you how to answer questions when items must stay together. So for 4.2, once again, it says 3 of the learners must sit together. So therefore, 1, 2, 3 learners must sit together, so we'll group them, which will leave us with 5 learners. 1, 2, 3, 4, 5. I'm representing them with the stick figures. So therefore, these 3 learners can be represented in 3 factorial different ways. And we now have 1, 2, 3, 4, 5, 6 items that we can now arrange. Now, the reason we have 6 items that we can arrange in 6 factorial different ways is because this group of 3 learners will now be counted as 1. So therefore, 3 learners can be represented, or they can be seated in 1, 2, 3 factorial different ways, times they will now be 1 group, plus the other 5 learners will be 2, 3, 4, 5, 6. So therefore, 3 factorial times 6 factorial. So now they can be seated in 3 factorial times 6 factorial different ways. And that's 4,320. In 4.3, in how many different ways can the 8 learners be seated if 2 particular learners refuse to sit next to each other? So for 4.3, if 2 learners refuse to sit next to each other, Let's answer the question by working the number of ways that we can have the two learners sitting next to each other and subtract it from the total number of ways that they all can be seated together. So let's put them together. So we'll put the two learners together, and then we'll have 1, 2, 3, 4, 5, 6 other learners that can be arranged in any order. So therefore, this will now be 2 factorial times, remember this is one group, 1, 2, 3, 4, 5, 6, 7 times 7 factorial. Therefore, the number of ways that we can have them not seated next to each other will be 8 factorial minus 2 factorial times 7 factorial. And let's work that out. So 8 factorial minus 2 factorial times 7 factorial equals 2. And that's 30,240 different ways. So once again, learners, this question was to highlight seating and to look at the number of ways learners can be seated together. If you haven't already subscribed, don't forget to subscribe to JL Maths. Also, watch all videos in all grades on jlmaths.com, and I'll catch you in the next video.